So hello guys, welcome to Prof1 YT channel. So with this video, we're going to look at the chapter 2 of calculus and analysis, and with this we're going to look at the point set, that's neighborhoods and limit point, bounds, and also the Bolzano theorem. So be with me to the end of the video, and with this please kindly pay attention with this because some of the theorem are very confusing, right? So let's move on. So the first we're going to talk about is the point set. Now when we talk about point set, any set whose number or whose member are real numbers is called one-dimensional point set. So all elements of a point set can be located on the real number line, right? So as you can see that any set whose member is a real number is called 1D point set. Now let's move on to the interval. Now when we talk about an interval, you know there's interval between something and something that becomes the interval, right? So the set of values of s such that x is greater than or equal to a, which is less than or equal to b, where a and b are all subset of what? Real numbers, right? It's a closed what? Interval. So now, the difference between a closed interval and an open interval, and also we have half open and half closed, right? So now, with a closed interval, it is represented by the square bracket c. So whenever you see two numbers in a square bracket, it means that it's a closed interval. What does it mean? It means that the interval doesn't exceed the a and the b. It is, see this is x is greater than or equal to, so a is what? Inclusive and b is inclusive, right? But with the open interval, see this, a is not inclusive and b is not inclusive. Therefore with that one we use what? Parenthesis for those set. So that's the difference between the closed interval and the open interval. Now we have the half open and half closed. Look at this. With the half open, it means that a is not part but b is part. As you can see that, you see here, x is greater than a but less than or equal to b. It means that b is inclusive but a is not part. And with this we have x being greater than or equal to a but less than b. It means that a is part because a is using a closed square bracket and b is using parenthesis. Now let's do something here. For example, a number is given to us for us to find something. So look at this. We have 4 and this is 1. So these are two numbers and we are supposed to list the members. It means that it's starting from 4 and ending at 1. It is closed. So 4, 3, 2, 1, right? But imagine that this side is having an open parenthesis. It means that it's going to increase. So if you are starting from 1, 2, 3, 4, 5, it can increase up to what? Positive infinity. So you should note that the difference between the closed interval and the open interval. Please note that, because with some question they can ask you to find the limit point or find the upper bounds and the lower bounds. We'll move on with that, but I don't want to. I just want to give you some brief on that, right? So let's move on. The one I'm going to talk about is neighborhood. You know neighborhood and limit point. A neighborhood is the area in which you live, so you are inclusive, right? Which makes you a member of the what? The neighborhood, right? So the set of all points x such that x minus a, which is less than sigma, where a is what? Or what? A subset of real numbers, but sigma should be greater than 0, is called sigma neighborhood of what? The point A. So we see this one. Now look at how this is arranged. It's sigma neighborhood of what? Point A. So it is sigma neighborhood of the point A. What it means is that the A represents the center, right? So the A represents the center and the sigma represents the neighborhood. Now mostly questions are giving into us that, for example, look at this, is one neighborhood of 0. It means that the 1 represents the sigma and the 0 represents the A, which means that the A is the center. As you can see, represent on the normal line, this is A being the center. Now let's go here and see something new. Now, you know the absolute value of x minus a should be less than sigma. Now when you simplify that, you're going to get that negative sigma less than x minus a less than sigma. Now we are trying to find the interval, right? So you're going to send a here, we can solve for this side and also solve for this side. And when you solve for each other, you're going to get that A minus what? Sigma is less than x less than A plus sigma. Look at this. We solve, you take this one, this side, you're going to solve, and after you're going to take this side and you're going to solve. And when you do that, you're going to get the interval for this, right? Now, please, this is the main thing you must know about the neighborhood when we are talking about the neighborhood. Now, let's look at something. We have something called the deleted neighborhood. When we talk about deleted neighborhood, it's all the interval, but A is not part. So you are in your neighborhood and you wake up and you're not there anymore. It means that you have been deleted from your neighborhood. So you're not part of it. So you are the A, which means the center is not part, right? Okay, sure. So we need to note something here. The sigma neighborhood of A is an interval with the center A. So the A represents the center. And whenever they ask you to find the length of a neighborhood, it is 2 times the what? The sigma. Let's see something here. So this is how we can represent it on the number line, because the A represents the center, and therefore from what we did here, finding the interval, we are going to get A plus sigma and A minus sigma. Now from this, I'm going to teach you something from here. Let's do something. This question, right? They say that the one neighborhood of 0 is an open interval -1, 1, has a length of 2 and center of 0. Let's solve it for here. Now, how do you find the length? Now, one neighborhood of 0, look at how this is arranged. So the sigma neighborhood of A. Therefore, the 1 represents the sigma and the A represents the what? 0. So the 0 represents the A. So when finding the length, you know that the length is what? 2 times what? The sigma, right? 2 times the sigma. And 2 times the sigma, it means that the sigma is 1. 2 times 1 will give you what? 2. That's why we had the length to be 2 from this question. Now, let's look at the center. You know that the center is A. And now we know that A is 0. So the center becomes 0. Then how did they find this interval? How? Now, let's look at this. From here, we now know that the sigma is 1 and the A is 0. So let's look at something. 0 minus 1 will give you what? -1 from here. That's why you had -1 from here. And let's look at this. 0 plus 1 will give you what? 1. That's why they had the interval to be what? -1, 1 from this. That's why I told you that with this, you must take note of this because you use it to solve questions under neighborhood. Yes, under neighborhood. So with the deleted neighborhood, the deleted neighborhood of A is an interval with center A and length of 2 sigma, with the point A excluded. So A is not part of it. So is the environment excluding A. So environment excluding yourself represents the deleted neighborhood. Let's move on. Now we have something called a limit point. Now a limit point, which is the same as point of accumulation or the cluster point of a set A of a number, is a number I such that every deleted neighborhood of I contains elements of the set A. That is, for every sigma being greater than 0. So with this, what it means is that since sigma may be small, we please, it is clear that the deleted neighborhood of 0 contains an infinite element of what? A. Yes. So look at this. Let's look at this. We should note this. No finite set has element point. So when we talk about finite set, a finite set is like a closed set. So look at this. Now, infinite sets, when you are writing them, you know that when you write them, you are going to represent them, the end start with what? These 3 dots. So it can be, you open the bracket and be 1, 2, 3, 4, 5, and you bring this 3 at the end. But with this, there's no 3. It means that it's what? A finite set. But with finite set, it has no limit point. Please note, no finite set has a limit point. Okay, sure. Now, let's look at something. An infinite set may or may not have a limit. In a particular, natural numbers n 1, 2, 3 has no cluster point. Do you know why? It goes, it's irrational, like it's rational, therefore it has infinite many limit point because it's going down. We don't know where it gets to because a natural number, if a set contains all limit points, it is called closed set. So look at this. The limit point is 0 and 1. It is a closed set, so it has a limit. When it moves, it gets to 0, it doesn't move again. When you move to 1, it doesn't go again. So it is from 1 to 0, 0, 1. And with that one, it is represented by the what we learned about the closed interval. That is the square bracket. It's a closed set. But with the open set, it is represented by the open interval, which means that, look at this, whilst the set open 1, 0 is not a closed set, since 0 and 1, even though our limit point, does not belong to the set. Yes, because 0 and 1 are not parts, as we learned from our previous one I talked about, right? Yes, so you should know this. Are you getting it? Yeah. Let's move on. Now let's take this example and try to solve this. With this example, they say how many limit points does the set bracket to be -1 and 1 have? Well, let's look at something. This is open set. So 0 and 1, -1 and 1 is not part. So it means that this will be going. So the limit of this number will be negative. So let's look at it. This will be negative infinity. And this will be what? Positive infinity. So the limit, though you see the limit cannot be -1 and 1 because -1 and 1 is not part. It's an open set. So the limit is negative infinity and positive infinity. Now let's look at this. Does the set 1/2, 1/3, 1/4 have any limit point? If yes, find them. Now this is having a limit point. One may say why. Now when you take your calculator, right, find 1/2 is 0.5. It will be what? Moving to a certain number. Now when you take 1/1000, it's moving to 0. Therefore, whenever you take 1/10,000, it's still moving to 0. Therefore, the limit point of this question is what? 0. Because when you take your calculator, this is a calculator way, and the rule is given to us that is 1/2, 1/3, 1/4, so 1/5, 1/6. Let's take 1/10,000. It's approaching to 0. That is the limit point. That is the what? The limit point. Now, when we take this, that is, and the limit point for this one to be half. For this side is half, and this side will be what? 0, because it's from half to 0. So it is a close interval. So half to 0, right? So half and 0 are the limit point. Let's find this. An infinite set is defined by A, 1/2/n. Now, does it have a limit point? If yes, determine it. This also has a limit point because when you put this are whole numbers, put it inside, take maybe 10,000, it's approaching to 0. So the limit point is 0. Because when you put huge number inside n, they've given you n is from 0 to infinity. So let's put a huge number, it is approaching to a certain number. What number is it approaching to? It's approaching to what? 0. Meaning the limit point is what? 0. Yes, let's move on. Now when we talk about bounds, right? Now, bounds is like a boundary. You cannot move, you cannot exceed. So it's like two wall, you are inside, so the two wall becomes boundary, right? Now with this, now let's look at something. We have the upper boundary and the lower boundary. Now the upper boundary is represented by capital M and the lower boundary is represented by what? Small m. What it means is that the huge number becomes the upper boundary and the lower number becomes the lower boundary. Now let's take something here. Let's take this question. They say that the set, it is an what? Closed set, that is 0 to 1, is bounded since example this and that. So they're talking about we have the least upper bound and the greatest lower bound. Look at this, the least upper. So you just look at the upper, right, and the lower. Look at this. The least upper bound is 1. It is the least upper because it is part. After 1, you have 2 to be greater than what? 1. So it's the least 1. And the greatest lower bound is what? What you must consider is not about the greatest, but look at the lower bound. It is the lower bound and the upper bound. So the lower bound is 0 and the upper bound is what? 1. Now let's look at this. They say that the least upper bound is 1 because the least one is 1. And the greatest lower bound is 0 because it's moving to 0. I told you that the upper bound is the highest number and the lower bound is what? The lowest number. Don't be confused with the greatest and the least. Just check for the upper bound and the lower bound, and it will help you solve this question very simple. Are you getting it? Don't be confused with the least and the greatest. Check for the lower and the upper. Let's move on. Now we have something called a what? Bolzano theorem, which states that every bounded infinite set has at least 1 point. That's one limit point. So every bounded infinite set, because with finite set they have no what limit point, but infinite set has at least one what. And with this, you know that this is approaching to something. That will be the limit point of it, right? And it's approaching to what? So the limit point 1/8. So it is 1/2, 1/8, so 1 over maybe 1,000. You're going to approach to 0. It means that the limit point is now what? 0. X has at least one limit point by the Bolzano theorem. That the limit point is 0 because it's approaching to 0. Yes. Thank you very much for watching this video. This is the chapter 2 of the calculus analysis, and I'm going to bring you the chapter 3 very soon. Thank you very much. If you are here new, please kindly subscribe for more videos. Thank you.